Hi, welcome to Physics Teacher, the channel that prepares you for the Waterloo Math and Science Contest. This is a grade 11 Hypatia contest question. It is question number 4, the last question of the 2021 contest. And there are 4 parts to it. Parts A and B are fairly simple for grade 11s, and then C and D gets more challenging, where D says, suppose that here x, y, and z, the sides of this triangle, are integers, and that the perimeter is 510, and that the area equals k times the perimeter, where k is some prime number. And then it asks for all the possible values of k. Give it a try, and I'll be right back with the solutions. Alright, so let's start with part A. Part A is fairly simple. We have a right angled triangle, and it's saying side x has a value of 20 and side y has a value of 21, and it's asking for the area and the perimeter. Well, to find the area, we don't even care about what z is, because the area of a triangle is just 1/2 base times height, where our base is 21 and our height is here 20. And so we get an area of 210. Now to find the perimeter, we're going to need to know what z is. But z, we can use the Pythagorean theorem, where x squared plus y squared equals z squared. And we know what x is, so we have 20 squared. And we know what y is, 21 squared. That equals z squared, but if we take the square root of both sides, we will get z to equal 29. Therefore, we can find the perimeter, which is just going to be x plus y plus z, to be 20 plus 21 plus 29, which will have a value of 70. So there's part A. Moving on to part B, it says if z is 50 and the area is 336, what's the value of P? Alright, so let's start with the area. So the area equals 336. And we also know the area is going to be 1/2 base, which is y, times height, which is x. And that's going to equal 336. Or if we multiply both of the sides by 2, then we will get yx equal to 672. Alright, so let's just leave that for now. And let's apply the Pythagorean theorem to this right angle triangle. So we'll have x squared plus y squared is going to equal 50 squared. Now x squared plus y squared I can change into x plus y all squared minus 2xy. Because you'll note if x plus y all squared, if you expand and FOIL that, you'll have a term of 2x plus y. So to make sure these left sides are equal, I'm going to subtract that 2x plus y. And that's going to equal 50 squared, which is 2,500. So I'm just going to rearrange to x plus y squared is going to equal 2,500 plus 2xy. Now I know what xy is. I solved for that over here. It's 672. So x plus y squared is 2,500 plus 2 times 672. Now if we add those and take the square root of both sides, we'll get x plus y equal to 62. Now since we want to know the perimeter is x plus y plus z, but x plus y, I know now, x plus y is 62, so this perimeter is going to be 62 plus our value for z, which is given as 50. So our perimeter is then equal to 112. And that's part B. Alright, so moving on to part C now. Things are going to get tricky here. It says determine all positive integer values of x, y, and z, for which the area is exactly 3 times the perimeter. Alright, so let's start with this area equals 3 times the perimeter. Now we know that area is 1/2 base times height, so we have 1/2 xy. And that's going to be 3 times the perimeter, where our perimeter is just x plus y plus z. And again, multiplying both sides by 2, we get xy equals to 6 times x plus y plus z. Alright, so I'm going to continue manipulating this a bit. I'm going to start by distributing the 6 into x, y, and z, and then I'm going to solve for 6z. So what I'm going to have here is xy, and then we're going to minus that 6x, bringing it to the other side, and minus that 6y, bringing it to the other side, and I'm left with 6z. Next thing I'm going to do is I'm going to square both sides of the equations. And then I'm going to expand. So this is going to get a little messy here. So we have xy squared minus 12x times xy minus 12y times xy plus 72xy plus 36x squared. I told you it was going to get messy. Plus 36y squared. And that's all going to equal to, here we have 36z squared. Alright, so next, notice in these first 4 terms, there's a common factor of xy. So I'm going to pull out an xy. So we have xy all times by xy minus 12x minus 12y plus 72. And then what I want you to notice here, we have a 36x squared and a 36y squared. But z squared, looking at the Pythagorean theorem, z squared is x squared plus y squared. So if I expand that, all these terms will cancel, and I'm left with simply 0. Now since I know x and y are positive integers, I know they're not going to be equal to 0, so I can divide both sides by xy, and they're going to go away too. So it's not going to stay complicated. We're going to simplify this, and we're going to simplify it even some more. So in these first 2 terms, I'm going to pull out a common factor x. So I'm left with y minus 12. And then I still have that minus 12y, and I'm going to bring 72 to the other side of the equation, making it negative. Alright, so let me rewrite this at the top here, and I'm going to make some space so I can continue doing some algebra. Alright, next step is, since I know that 12 and 12 multiplied together gives me 124, what I'm going to do is I'm going to add 124 to both sides of the equation. You're going to see why in a second. So 144, that's 12 times 12, equals minus 72 plus 144. So now right here, I have a common factor, and that is 12. But I'm going to pull out a negative 12, so I am left with, so minus 12 is going to give me y minus 12. Now you see why I did that? So now I have a common factor between these 2 terms, and that's all going to equal to 72. So if I pull out that common factor, I am left with x minus 12 times y minus 12 is equal to 72. So what does this tell us? Well, I know that x and y are positive integers, simply because we can't have a negative length on our triangle, and because the question says that they are integers. And I also know that this term here, x minus 12, multiplied by this term here, gives us 72. Now since x and y are integers, both of these terms are integers, and therefore they're both factors of 72. Now it is possible these terms x minus 12 and y minus 12 are negative integers. Right? X and y must be positive because they're the length of the sides of a triangle, but there's nothing saying that these terms must also be positive. Now for these to be negative integers, it would mean that x and y are less than 12. Now there's a couple triangles where x and y can be less than 12. For example, we have our 3, 4, 5 triangle. Right, that is one example. So if we looked at this example, then we would have, well, x is 3, so we would have 3 minus 12. Y is 4, so we'd have 4 minus 12. And that would give us 72. And that's true, that works. However, if we were to solve for the area, which is 1/2 base, so 4, times height, so 3, that is going to equal 24. And then if you're to solve for the perimeter, which is 3 plus 4 plus 5, that is going to equal to 12. And looking at this area is not equal to 3 times the perimeter. So this triangle of 3, 4, and 5 is not going to work. Now there's another triangle we can make with integers where x and y are less than 12, and that is 6, 8, and 10. Now you can try this again yourself, find the area and the perimeter, but again, the area will not equal 3 times the perimeter. So this tells us that this term x minus 12 and this term y minus 12 are going to need to be greater than 0. So x minus 12 is going to be greater than 0, and y minus 12 is going to be greater than 0. So they're going to be positive factors of 72. So to figure out which ones are going to work for us, let me rewrite this equation again at the top, and we're going to create a chart. So in our chart, we are going to have different factors of 12, a factor pair of 12. So what two integers, positive integers, can be multiplied to give you 72? Well, the first and obvious one will be 1 and 72. You can also have 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. Alright, so let's then look at what x minus 12 would be, and what y minus 12 will be. Now in this example, I'm going to make x minus 12 the smaller factor pair, and y minus 12 the larger factor pair. And I'm going to do that for every example, but we have to realize it can go the other way as well. But there's symmetry involved there. Right? It doesn't really matter which side I label as x or y, as long as neither of them are the hypotenuse of our triangle. And then we're going to solve for x and y. So for x, well, if x minus 12 is equal to 1, that must mean x must be 13. Similarly, if y minus 12 is equal to 72, that must mean that y is equal to 84. Finally, we could figure out what z would have to be using the Pythagorean theorem, where z is equal to x squared plus y squared. And in this case, you're going to get z equal to 85. So this gives you two possible answers for x, y, and z. The first being, for x, y, and z, we have 13, 84, and 85. The second being, just like I said, you can alternate or switch x and y. So you could also have 84, 13, and 85. So you're going to get two answers for every factored pair. Now all we have to do to finish the question is to finish the chart. And there you have it, 12 different possible solutions for part C. Alright, so moving on to part D, our strategy for solving part D isn't too dissimilar from part C. So let's start with A equals KP, where K is some prime number. Well, again, we know that the area is just 1/2 base times height, and that's going to equal K times our perimeter, which is just x plus y plus z. And again, multiplying both sides by 2, we get xy equals to 2k times x plus y plus z. Then, just as in part C, I'm going to distribute this 2k, and then I'm going to bring my x and y terms to the other side of the equation. So I'm left with xy minus 2kx minus 2ky, and then on the right side of the equation I have 2kz. Then we're going to square both sides. And just as in part C, this is where it's going to get messy. So let's expand this trinomial here, all squared. And we get xy squared minus 4kx times xy minus 4ky times xy plus 8k squared xy plus 4k squared x squared plus 4k squared y squared, and that is all going to equal 4k squared z squared. Now again, just as in part C, if we look at these first four terms, I can pull out a factor of xy, which is going to leave us with xy all times by xy minus 4kx minus 4ky plus 8k squared. And then, just as before, these two terms are going to cancel with this one, because if we remember, z squared by the Pythagorean theorem is equal to x squared plus y squared. So these are all going to cancel, and we're left with this all equaling 0. Then we can also cancel out our xy term, because we can divide it by both sides of the equation, since again we know that x and y are both positive integers, so 0 divided by xy is just going to be 0. Now in our first two terms, I can pull out x as a common factor, so we'll have x all times by y minus 4k. And then I still have this minus 4ky. And I'm going to bring this 8k squared to the other side of the equation, so we'll have minus 8k squared. Now here we have a 4k and a 4k. So what I'm going to do is add 16k squared to both sides of the equation. So you have x times y minus 4k minus 4ky plus 16k squared is going to equal to minus 8k squared plus 16k squared. So now you can see here what we have here is a common factor of minus 4k. So I'm going to pull that out. So we're left with x times y minus 4k. That's not changing. And then we're going to subtract a 4k, because we're going to factor out a negative 4k, which leaves us with y minus 4k. So now you can see again why I did that. We now have a common term here and here. And that's going to equal to, well, these are like terms, so I can just add them and we'll get 8k squared. So now if I pull out that y minus 4k, and I'll write this right at the top, we have x minus 4k all times by y minus 4k is going to equal 8k squared. So here's the equation we're going to work with. Now let me give myself some room. Now we know that x, y, and k are all positive integers, which means that each of these terms, x minus 4k and y minus 4k, are also positive integers and are therefore going to be factors of 8k squared. Alright, let's start off this problem by assuming that k is going to equal 2. That's a very small prime number there that we can work with. And if we do that, if we sub in k equals 2 into this equation, we're going to get x minus 8 times y minus 8, which will equal, well, 8 times 2 squared. That is going to equal 32. Well, if we look at this, well, 32 is a positive value. That means that this term and this term are either both positive or both negative in order to get positive 32. Now, if they're both negative, that would mean that x is going to be less than 8 and y is going to be less than 8. But remember, the perimeter is 510. You're never going to reach a perimeter of 510 if both x and y are less than 8. So this is actually not possible. We're not going to have these two terms both being negative. They're going to have to both be positive terms. All right, let's assume that x is going to be smaller than y, just like in this diagram. That doesn't really matter. They're interchangeable because they're both the sides of a right-angled triangle, which are not the hypotenuse. And it could also be possible that x is equal to y. That would mean that x minus 8 could have a value of 1, 2, or 4 in order to be a factor of 32. And that would mean y minus 8 would either be 32, 16, or 8. right? Because 1 times 32 is 32, 2 times 16 is 32, 4 times 8 is 32. So there's our factors of 32. And that would mean, well, for example, if x minus 8 is 1, that would mean x would have to be 9. Or if x minus 8 is 2, then x would be 10, and so on. X can be 9, 10, or 12. Similarly, this means y can be 40, 24, or 16. And then you can use the Pythagorean theorem that says our hypotenuse, z squared, is equal to x squared plus y squared, and come up with your values for z to be 41, 26, and 20 respectively. But again, if you were to find the perimeter, which is just x plus y plus z, with any of these combinations, for example 9, 40, and 41, they do not reach 510. So what does this tell you? This is too small of a value for k. Now you can also do the same analysis with k equals 3. And it's not going to work. K cannot be 3. K cannot be 2. So what we're left with is that k must be at least greater than or equal to 5. K certainly wouldn't be 4 because it says k is a prime number. So let's stick with this for now. Now, since k is a prime number, we know that these two terms are going to be factors of 8k squared. And those factors can either be 1 and 8k squared, because 1 times 8k squared is 8k squared. Another option is 2 and 4k squared, 4 and 2k squared, 8 and k squared. And then we also have k and 8k. And finally, we also have 2k and 4k. And this is again assuming that x is going to be our smaller side of the triangle. Now, just as before, we also have all the same factors, but all negative. If we replace each of these values with the exact same negative value, this would also satisfy the equation. For example, you could have minus 1 and minus 8k squared. But let's look at this. So if x minus 4k is going to be equal to negative 1, and y minus 4k is going to be equal to negative 8k squared, then rearranging to solve for y, we get y equals negative 8k squared plus 4k. Well, look at that there. We know k is going to be greater than or equal to 5. That means y is negative. We can't have y to be negative because they are all positive integers. Integers that have a length. So y cannot be negative. So we cannot take our negative terms here. Both these terms, again, must be positive terms. So let's just stick with these positive factors. And now let's move to this idea that the perimeter must be equal to 510. So we're going to have x plus y plus z equal to 510. So I'm going to perform some algebraic manipulation on this. So we're going to have x plus y, bringing z to the other side of the equation. We have 510 minus z. And then squaring both sides of the equation and expanding those squares, we're going to get x squared plus 2xy plus y squared. That's what you would get when you FOIL that. And we do the same thing for the other side of the equation, and we will end up with 510 squared minus 1020 times z plus z squared. Now, again, due to Pythagorean theorem, we know that x squared plus y squared is going to equal z squared. So those are going to cancel out on both sides of the equation. And we're just left with 2xy is equal to 510 squared minus 1020z. Now let's look at the area. So the area, let me write this over here. The area is 1/2 base times height. So 1/2 x times y. Now here you have 2xy. So that's 4 times the area. So I can replace 2xy with just 4 times the area, where I know the area is equal to kp, where p is 510. So that is just 510k, which again is still equal to 510 squared minus 1020 times z. Now you can just divide every term by 510 and then further by another 2, and you're going to end up with 2k is equal to 255 minus z. All right, so let me just write that over here, and I will free up some room, and we will continue. Now I can go a little bit further with this, so I'll have 2k here, and then we have 255. Now because the perimeter is equal to x plus y plus z, I can rearrange for z and say that z is equal to the perimeter, which is 510, minus x minus y. And so now rearranging this equation, we can get x plus y minus 2k is equal to 255. All right, so giving myself a little bit more room, let's analyze this equation with our first factor pair right here. All right, so this says that x minus 4k, so x minus 4k is equal to 1. It also says that y minus 4k is equal to 8k squared. Now if I rearrange for x and y, I'll get x equals to 1 plus 4k, and y equals to 8k squared plus 4k, and substitute those back into, let's call this equation 1. Then what we get from equation 1 is 1 plus 4k plus y, which is 8k squared plus 4k minus 2k, which is equal to 255. All right, so if I collect like terms here and simplify, I'll have 8k squared plus 6k is equal to 254. And I can factor out a k to give k times 4k plus 3 is equal to 127. Now there's a problem for solving for k then, which is what we're trying to do, is find all possible values of k. And it looks like with 1, 2, 3, 4, 5, 6 different factor pairs, we might be able to find 6 values for k. But in our first factor pair, we have k times 4k plus 3 equal to a prime number. Well, since k is greater than or equal to 5, so k cannot be 1, there's no solution here. Because a prime number is defined by the fact that you cannot take two integers greater than 1, multiply them, and get that number. So there's no solution here for k. Now what we're going to have to do then is test these other factors. Right? All 6 of these factors. We know the first one doesn't work, but we need to test the other 5 to see if there's any solutions for k. If you like, you can pause here and take a moment to try that for yourself. Otherwise, I am going to continue with the solution once I give myself a little bit more space again. Alright, so I'm going to create a little chart here that'll help us go over all those other factor pairs. So let me put a factor pair here. And we'll start with 2 and 4k squared. That's our next factor pair. And then I will solve for x, and I will solve for y. In this case, x would be 2 plus 4k, and y will be 4k squared plus 4k. Doing the exact same steps we did to analyze that first factor pair. I'm just summarizing in a chart. And then we're going to look at equation 1, and we're going to simplify that equation 1 after we substitute our x and y values into it. And then we're going to solve for k. So I hope you tried these on your own. With our first factor pair, you should be able to simplify equation 1 after substituting x and y into it to get 4k squared plus 6k is equal to 253. Again, this is a problem. Why is it a problem? Because our left side is going to be an even number because we're multiplying by a 4 for this term, by a 6 for this term, and our right side is an odd number. So you're never going to get an integer value of k. So again, no solution or no k value. For our next pair, we will get x to be 4 plus 4k and y to be 2k squared plus 4k. And if you substitute those into equation 1 and simplify, you will get 2k squared plus 6k equals to 251. And for the same reason, the left side is even, the right side is odd, we get no value for k. So we haven't found a single value for k yet. But let's try our third factor pair. Our fourth factor pair, 8 and k squared. All right, so if we solve for x, we get 8 plus 4k, and y is going to equal k squared plus 4k. And substituting those into equation 1 and simplifying, we get k times k plus 6 is equal to 247. And in this case, you can solve for k. K is going to equal 13. So we have one possible value for k. Let's try the other two factor pairs, see if there's another. So the next one will be k and 8k. Solving for x, we get 5k. Solving for y, we get 12k. And substituting those into equation 1 and simplifying, we get 15k is equal to 255. Once again, we can solve for k. K is going to equal to 17. So now we have two possible values for k. And finally, our last factor pair, 2k and 4k. Solving for x, we get 6k. Solving for y, we get 8k. Substituting into equation 1 and simplifying, we get 12k is equal to 255. This does not give us an integer value for k. Again, the left side is even and the right side is odd, so no k. So for part B, there are two solutions for k, 13 and 17. I hope this video helped. Please be sure to subscribe to support more videos. And if you have any other suggestions, let me know in the comments.